Hello world, and welcome to the stream, to this special stream. I'm really excited. Today is the first episode of our Web API Wednesdays, and we're talking about WebGPU today. So yeah, let's do it. Here we go.
I am not an atomic playboy.
10 seconds of transmission. Transmission.
Hello everyone,
Transmission.
and welcome. I am so excited. We are going to do this today.
Transmission.
Let's see if everything is up and running. Hopefully it is.
Transmission.
Hopefully it is. So, yeah, I've been thinking about this, and we are planning this for, I think, a couple of weeks now. And the idea is even older. Yeah, we're going to do a very special stream today. Let me go over here. Yeah, let's just go right into it. Let's just don't do anything else. Don't do any cool other news. Let's just go into it. So today I have a special guest, Donnerknalli, one of the regulars on the channel, is also streaming on Twitch. Let me see if I can have Rosie do a shout out. Yes, it works. So you should go there, follow, and on his streams he is talking about WebGPU a lot. And I thought what better idea would be to have him on the channel talking about WebGPU today for the very first Web API Wednesday. And if it's a success, I will see if we can have other people going on and explain something else. So Donnerknalli, also known as Daniel, but I think we should just call him Donnerknalli. We all know him here. He's a lead developer. He works on mobile apps and web front-end components, and also is doing WebGPU. If you have any questions during the stream, just drop them in chat. I will collect them, and yeah, we can. At the end, there's a lot of time left for doing questions. So feel free to drop them in chat. We will answer them. So yeah, I think we should bring in Donnerknalli. If it works, it's not working. I thought it should work. Yes! Donner, welcome. You are muted, I think.
Hello, all, and welcome to the stream.
How are you doing today?
I'm doing fine, thanks.
Is everything okay
So
on your end?
I have a bit of adjustment here. So I don't have an echo, so I mute the stream and using your voice in Discord.
Yeah, so
we both have no delay.
yeah, on my end, the audio sounds pretty good actually. I'm amazed with the setup we came up with. So this is the first time I'm doing this on stream. I did some interviews for the Live Coders conference.
Yeah, me too. it's also my first time to doing things like this kind of co-op stream or dual stream.
Yeah, it is, and I think until what we've tested, it worked pretty solid, pretty cool.
Yeah, I think I should move my camera a bit. Oh, stream delay is interesting there. Wrong direction.
So yeah, you are doing WebGPU.
Yes. The last few weeks, I'm trying out myself to get my hands dirty on WebGPU and try to start with a normal hello triangle. In the programming slang, we call it hello world, but in the graphics programming, we call it hello triangle. So you try
Yes.
to first render your first triangle on screen. And this was the first thing I tried to achieve. And there are some documentations out there from other developers, from Google or from Mozilla. But it's hard to find everything together and get it running. So I have to deep dive into example codes and have to try out many, many things. And I pull out my hairs during the debugging sessions when you only see a black screen and nothing more, and then you have to look through a few lines of code and find the error. Yeah, that was a bit of problematic, and some things you can't debug. Shader things are not debuggable, and most of the things are really like black boxing. So you allocating things on JavaScript side for buffers, and then you send the buffer to through the web API. Yeah, that were the problems I had, but at the end I figured out something and then reworked and refactored and so on.
But there's not a lot of tooling, right? You debugging is just like commenting out a line and see if it works.
Yes, exactly. Commenting out, changing some parameters, trying other things, try to understand the whole architecture, and yeah.
Oh man, yeah. There's already a question in chat. If you're one of the White Rabbit guys,
no, I'm not one of the White Rabbit guys.
No, it's not. Could be. They're. I'm not sure they're doing WebGPU. They're really deep into graphics and WebGL. I know, but yeah. Yeah, I don't have any more questions for now. I think we should just let you do the rest of the talking.
Yeah.
So I'm going to give you the floor, and I will interrupt you if needed.
Yeah, thanks. That's good.
So go ahead.
Yes. Welcome to my talk about WebGPU. It's a little introduction of what WebGPU is and what's the benefits, and later on we will get into a little bit of a demo. So first, let me introduce myself. My name is Daniel. My Twitch account is Donnerknalli. Here is my Twitter account and also my GitHub account. Every demos I present from myself are available on GitHub, so you can look at the code. You can also ask me some questions, and hopefully I can answer them. We also planned some kind of question and answer at the end of the talk, and so if you want, write down your questions in chat, and source code will copy them later, and then I try to ask them. So what exactly is WebGPU, and who does developing of WebGPU? WebGPU itself is nothing more than a web API. It's developed by the W3C group, and they have W3C GPU group for this. It's mostly driven by community, but also it's driven by Google, Mozilla, Microsoft, Intel, and Apple. And the group repository is open, so everybody can create an issue with spec and everything, and can look at it and can contribute to the specification for WebGPU. So maybe the first question is, why WebGPU? At the moment, we have WebGL, which is supported by all major browsers. And why do we need another API? So WebGPU will be the successor of WebGL. And the reason why all companies like Google, Mozilla, Apple have started specifying a new API is better CPU performance. So they want less main thread blocking during drawing. And so the browser have time to do more cool things like physics and so on. And you have less blocking. And the whole render pipeline is more predictable. Another thing is WebGPU supports computation capabilities. We will look deeper into this later. And what also is an interesting thing is that they want to have an API which is based on the more modern native APIs like Vulkan or Direct3D 12, which is the part of DirectX 12 on Windows, and also the Metal API on Mac. And possible there will also be an OpenGL support, but this will be a kind of a fallback. WebGPU will be available on all modern major browsers. So it will be available on Chrome, Firefox, and Safari. And hopefully it will also be available on mobile. But for this, I'm not yet sure. But it looks like they will support on mobile, at least on Android via Vulkan. But hopefully Apple will also make it happen to support it, to fully support it on Safari iOS. So first thing is better performance. Better performance means it will not draw faster on your GPU because your GPU is the same, but it will draw more efficient. This means you have more work to do during setup before you start drawing your first frames, but then you have lesser cores during draw. This means lesser CPU time during draws and lesser overhead during each frame, and which can lead into better frame rates also. WebGPU is also designed from the ground that you can do preparation in web workers. So you can do parallel loading of models, parallel creating of geometries, and so on and so on. And right now we will jump into a first demo, which is made as implementation by the family known Babylon.js. They have created a demo, and here is the comparison. This is the called Forest WebGL. It's a WebGL implementation of their demo. And here you see I have on my machine a frame rate about 35, 37 or 40 frames. But the other thing is I have CPU of nearly 30 milliseconds CPU time per frame. And it's a heavy scene with many, many trees here. And if I zoom out this scene, it begins to lagging. The CPU time jumps up to nearly 60, 70 milliseconds per frame, and the frame rate goes down to 50 frames per second. Then they show up the same scene in the WebGPU implementation. And here you see I have a little bit more frames, about 45 to 45 to 50 frames, but the CPU time is very, very low. And if I zoom out the whole scene and show every tree, I think there are 10,000 of trees. I see I have still the same frame rate, so no performance bottleneck here, and the CPU rate is still the same. So jump back to the other implementation, wait a bit that the browser can settle, and comparing the numbers. So this is the implementation for WebGPU on the Babylon JS framework. I think they have not yet released it. It's still in development, but as far as the WebGPU specification gets official, they will release it. Okay, next thing is compute capabilities. At the moment in the browsers, with WebGL1 or even with WebGL2, there is no compute capability because WebGL1 is specified against OpenGL ES2 and WebGL2 is specified against OpenGL ES3. And compute shaders were introduced in OpenGL ES 3.1. Yes, and if you hear the numbers, then you see that OpenGL is a bit of version hell. We have many versions on desktop and ES and there, and and then we have WebGL1 and WebGL2, and you should exactly know where to look at Chrono's website if you want to know what is implemented where. And yeah, this means at the moment we have no capability of computing with WebGL2. There is one exception. The Intel group, the Chinese Intel group in Shanghai, had created an extension to WebGL2 which supports compute shading, but this is not official. It's available in Chrome. You can turn it on, but it is not official. And we all doesn't know if this will become official one day. Another advantage of WebGPU compute will be that you can use compute pipelines without a canvas. So with WebGL, you had to create a canvas, you had to create the whole initialization of WebGL, and then at the end, only when you want to compute things like doing heavy physics computations or any simulations. The plan for WebGPU compute is that you can do this without a canvas. So at the end, maybe you can use this offloaded on a Node.js process or something. It's only a theory. I have not tried it, but somewhere they described it. Another thing is you can do buffer sharing between compute and render pipelines. So you can create a buffer, manipulate it during compute pipeline, and then read in the render pipeline for rendering. So that's a little bit of the architecture if one is interested in here. It looks very complicated. And it was not very easy to figure out everything. There is the basic initialization. You have an object on, it's a typo. It should be called navigator, not navigator. On the navigator, there's a GPU object, and with this GPU object, you can request an adapter. With this adapter, you can request a device. And from there on, you have a GPU device, which do everything on this. Then you start creating a swap chain. And with this swap chain, you're using your texture attachments and also the depth stencil attachments. This swap chain should be recreated on every canvas resize. So when you're changing the size of your canvas, and for the swap chain, you are requesting the context from the canvas with the GPU present string, like you do with WebGL. And then comes the render pipeline. It's a big initialization, which is happening before rendering. Here, every buffers are created for the vertices and also for bind groups. Bind groups are used for uniforms, where you can put in values into your shaders. And also you have to create your shader modules for the vertex stage and fragment stage. In this kind, I have not looked at compute or geometry stages and so on. Then you describe what you want to render. There's a called primitive topology, like you want to draw triangles or lines or points, for example. Then you describe your color stage, so how your buffer is cleared and what color format you want to use. And at the end, you have your state descriptors and rasterization descriptors. So these describe how your vertex state is built up and how the rasterization will happen during rendering. And so at the end, you have a big GPU pipeline object. And here is the draw loop. So during draw, you start to get a texture view from the swap chain where the GPU can render on. And then you start with so-called command buffers. So you create a command encoder where you can fill the command buffers and stick in the render pipeline and also your vertex buffers. And if you have indices for your vertex buffer, if you have indexed drawing or instance drawing or something, then you set this up and then you go. You can draw them. And after this buffer, it's nothing more than a list which tells the GPU what to do next. You submit this buffer to the queue, and that's the last step, and then the render will happen. And this will be the render loop. So each frame this happens. That's a bit of an overview of the ground architecture. I have not looked at all points in the architecture, but that's the main things. So what's interesting is the current implementation status. It's also available on the GitHub repository of the W3C GPU group. At the moment, implementation status on Chrome or Edge, which is Chromium based, is still work in progress. Chromium uses a C++ lib called Dawn. This is a cross-platform library in C++, which supports multiple backends. On Windows 10, Direct3D 12 and Vulkan is supported. On macOS, only Metal will be supported because maybe someone read it that Apple has deprecated OpenGL on Mac, and on some day there is no longer support for OpenGL on Mac, only Metal. Yeah, and on Linux and Chrome OS and Android and the upcoming Fuchsia, which will be maybe the successor operating system for Android. So it's the operating system developed by Google at the moment. And all these systems will support Vulkan as a backend. I have done my tests with Chromium, mostly with Chrome Canary, which is 86, but right now you can also use it on Chrome Stable, but you have to turn on Flex. So it's built in, but it's not available per default. I'm not 100% sure which backend will used on Windows. I think it will be Direct3D 12, but the Dawn library will also support Vulkan, so maybe it also works to switch to Vulkan, and maybe it will also support Windows 8 and Windows 7. At the moment, it only works on Windows 10. I think that's yeah, and on macOS Catalina, I tested also with Chromium, and I think there's the backend Metal. Current implementation status for Firefox is also work in progress. I mean, this is for all browsers. The Firefox implementation is based on the GFX RS / WebGPU project, which is based on GFX HAL. These are Rust libraries because most of major things in Firefox today are written in Rust. So their server render engine is Rust-based, and also the WebGPU thing is Rust-based. And this is also cross-platform, and this also supports multiple backends, as they announce. And it supports Direct 3D12 on Windows, and maybe as a fallback, Direct 3D11, which possible supports Windows 7 and Windows 8, but I'm not sure here. It will support Metal as a backend on macOS, and it will support Vulkan as a backend on Windows and Linux. And with the question mark, it maybe as a fallback, they will support OpenGL as a backend. Yeah, it also needs Flex. It is available in Firefox on the stable, which is 77. I tested with stable and I tested with nightly, and with both, unfortunately, I had no success with Firefox. Firefox 77 stable does not yet support the full spec of WebGPU. They are a little bit behind, and I'm using in my tests some newer things for buffer updating, and they are not yet supported by Firefox, but hopefully later they will be supported. And my tests on Firefox 79 nightly leads into crashes of Firefox, unfortunately. Yeah. So overall, this whole technology is still under development. Search, maybe interesting browser is Safari on macOS, and still also work in progress, and nothing very open here, as we know from Apple. So I don't know much about their implementation. But I'm nearly 100% sure that they're using Metal as backend. I also doing testing on Safari Tech Preview version 109, which was released, I think, 1 or 2 weeks ago. But this still does not work because they are, like Firefox, not have implemented the full spec at the moment. Yeah, that's about implementation status. So right now I have some demos, so we can switch back into a browser which supports WebGPU. It's Chrome Dev or Beta, I think. And yeah, here is a not very interesting Hello Triangle thing. I can also show some code if one is interested here. And this was my first implementation of WebGPU for myself. And then I move over to an older project I have done with OpenGL and WebGL, called it Particles, and now I call it WebGPU Particles. So let's do a quick reload. And unfortunately, it does not work. Yeah, fine. So let's close the browser and start it again. Yeah, here we're back. I have some links to special browsers where I do testing here, and there is nothing more than bring in the flags via command line, and they are all documented on the GitHub repo of W3C WebGPU. Yeah, here this project is a simple box where some particles live in. And the particles are calculated with WebGPU compute. The velocity and the position of the particles are calculated. And yeah, if I hit space here, I've implemented some force attraction. I can attract the particles. And if I release the space bar, they are falling down to the gravity law. And here I can adjust the particle count. And if we see, we have at the moment 100,000 particles, and we have an average CPU time of 0.100 milliseconds, which will be 100 microseconds. And I disabled VSync in my browser at the moment, and then I have a frames per second of over 400 frames per second, and the average frame time of 2 milliseconds. And I can crank up the particles to, for example, 5 millions. And I'm still good here on my machine. So the frame time is still under my 60 milliseconds for 60 frames. And the average CPU time does not really change much. So it will keep constant here. And the animation is still smooth. And I can also crank them up to 10 million particles. Hopefully it gets through the stream, maybe with a bit of lagging or a bit of quality loss. Yeah, I've also implemented the color changing for playing around. And here you see with 10 million particles, my frame time goes up to 25 milliseconds. So the frames per second will drop down to 35 to 40 frames per second. And it's not yet fully smooth, but still okay for, yeah. My hardware is GeForce GTX 1060, so it's a 4-year-old GPU, nothing very new and nothing high-end gaming. Yeah, and that's it for the demo. Yeah, and that's it for my talk. And I would say thank you to all. And now we can go into question and answer and maybe look into some of the code if one is interested here.
Well,
Yes.
I am interested in the code. That's for sure. Don't think we have any questions from chat. If chat has any questions, feel free to ask them. I do have a few questions. So, well, first of all, I was kind of surprised that it worked in WebKit. That there is, I'm not sure, I haven't looked into it, but just saw that it's there is support for WebKit, and that's like WebXR, what I worked with a lot. That's not supported, so I'm kind of jealous.
Yeah. Apple mentioned that they have started proposing the next web graphics, but at the end, some in the group are discussing that it's not true. So they are fighting a bit that who was first. And Google said, okay, they're starting 2016 with a proposal. Apple has started with proposals in 2017. At the end, it's very fine that Apple also will support it. And WebKit is never the problem. The problem is Safari. WebKit is open source, but Safari not, and Apple decides which goes into Safari. And but overall, we can be sure that Safari will support it, Firefox will support it, and also Chrome will support it. So Internet Explorer will definitely not support it, but it is already dead.
Yeah, by the time it is supported in the other browsers, I don't think anyone would use IE anymore. Maybe in an office somewhere, but I don't think they would really benefit from WebGPU.
No.
Now there are graphics is the most common use for GPUs, but there is also use for GPUs for doing all kinds of calculations. Like AI and deep learning.
Yeah.
Have you seen anything being done there with WebGPU? Can you use that for faster calculations in machine learning or deep learning or whatever?
Yeah, it can. I have not looked at this because I'm not a machine learning, AI, deep learning professional. I'm not doing anything with this directly. But as far as I read, TensorFlow, which is, I think, a library by Google, and it's also available as TensorFlow.js. The other thing is available via C++ and Python, I think.
Yes.
Hopefully I'm not wrong. They already have started implementing WebGPU. So I think at the day when WebGPU is official, so when the spec is freezed to like a version 1, and the browsers officially support it without a flag, then they have everything ready.
Yeah.
And it could be used for machine learning directly on the web.
Cool. I've been looking into TensorFlow and stuff a little bit with Python, but I didn't know you could do that with JavaScript as well. So it might be a nice idea to see what we can do there with Rosie and build some WebGPU stuff in Rosie. So if you don't know, Rosie is a chatbot that's running the channel. She does shoutouts and stuff. I made her quiet today. Although I think in the beginning there were a few alerts going off. I'm not sure if they were on stream or only on my side. Normally I would do like effects and shoutouts and stuff, but I disabled them for now. There's also a thing with like security. I know with pretty much all APIs I looked into, there is a big discussion about fingerprinting and just using it for evil. Do you know anything about that? Is there that I'm pretty sure it is a concern of the W3C there. But do you have any knowledge about what they're doing there?
No, I have not much knowledge about security. I read something. How do they abstract on Chrome with the Dawn library? So they implementing sandboxing here as they doing it for every other things. So each tab will run sandboxed and anything. But I think it will be a major thing, and hopefully they get everything secure like it should be. And mostly, I think if Apple is still on the train, it looks like that the security concept could work. So Apple is much in the security thing, and they try to get everything secure. Yeah. What's also interesting, what the the Dawn library mentions on its website. I put a link into the chat. It's the open source library by Google, which is the layer for the backend, and they will also implement like a client-server implementation of WebGPU for applications that are in Sandbox without access to native drivers. So, which does this mean? I'm not really sure, but I think that could be meaning that you can emulate the thing if you have a bad GPU or anything, and you can still program against WebGPU if you don't have a capable driver or a graphics card, which is very interesting. And yeah.
It is interesting. It is interesting. So like
And
it's kind of like a polyfill kind of.
yeah. So like this. That's the only sentence they mentioned for applications that are in Sandbox without access to native drivers.
That Dawn project seems pretty cool.
And this project also helped me out to debug sometimes, because when there is an error thrown in the console of the browser, you see a stack trace of C++ files with line numbers of C++ files, which is not common for any web API, as I know. But I think it's still for development. And you can do a Git clone of this Dawn library and can look into the source code and read the C++ source code and can maybe figure out something what you have done wrong with your code. And it helps me on some day.
Now you're talking about C++ as well. Does this work with a combination with WebAssembly?
Yeah, you can fully program do a WebGPU implementation on Rust, for example, and compile this to WebAssembly and get it running into the browser. But I have not tried this. I'm not familiar with WebAssembly at the moment, so I don't get on WebAssembly.
Me neither.
Just have to understand some basics of WebAssembly before trying out the big thing with WebGPU.
It might be a good one for a future Web API Wednesday, by the way.
Yeah, maybe.
maybe we could have a look at that. The last thing I was thinking of earlier, one other thing you can do with a GPU is mining things like bitcoins.
Yeah.
I assume it can be done through WebGPU as well. But is there any? So if you would use WebGPU for the first time, does it just run? Is it visible? You can do stuff without rendering to the screen. You don't need a canvas.
That's what they mentioned. I have not tested it, but somewhere I see a talk by a guy from Google, and he mentioned that you will be able to using WebGPU compute for within the website maybe, and it is not it's not needed anything to render on the screen. But for Bitcoin mining like this or anything, I think today it's not really interesting, because it costs so much power or anything else, even on native high-end GPU hardware, to mining Bitcoins, that you have more cost for the power consumption and for the hardware than getting from the Bitcoins.
That's true if you do it normal way, but I'm kind of a hacker.
Yeah.
And I was thinking about using like cross-site scripting and injecting some GPU mining, not Bitcoin. Bitcoin, I think you cannot mine Bitcoin anymore, but there are some other coins which you can mine still. Slowly, but
from theoretical, I think this will also be doable with WebGL. And there is also no shout out by the browser if you get a WebGPU context. And you can create off-screen canvas today with WebGPU. You can also create off-screen canvas in Workers today with WebGPU. And so it doesn't change anything. So you don't see anything on the screen. Maybe you hear the vents of your GPU when it
Yes.
cranks up.
Your computer starts making a lot of noise. Well,
Yeah.
there was this virus a while ago where there was this cross-site scripting thing with Twitter,
Yeah.
and so when you got that tweet, when you opened the tweet, you automatically were subscribed to that person, I think, and the tweet was sent. If you would like trigger something like that, and it would start mining in the background, I think if anyone that got it only mines a very, very small portion, but you have like 10 million people that only mine a fraction, you will mine quite a lot, I think. So yeah, I think we should build that. Do you have any code you can show?
Yes, if
I'd
you
love to see how
want.
it works. Yeah, I can give you the full screen again. Is you ready?
Yeah, sure. So it's one part is much code, and so I think let's look into the easier thing, the hello triangle code. And it's everything, I'm writing TypeScript people, nothing very complicated in here. So this is my, let's turn up the zoom a bit here. So it's easier to read. Yeah. So this is the main file. I have, like in WebGL, I have a canvas here, nothing more. And in the main file, I get the canvas element, and I have a render class, which is called WebGPU renderer, and feed in the canvas here. And at the beginning of this class, I initialize some things for the model view projection matrices, and then I have somewhere a start render function. In the start render function, I do the basic initialization. What's here on the architecture. So I look for this GPU object on Navigator. That is the main thing. And if this is not there, then I'm returning false because I cannot use WebGPU. And this is only available in a browser which has turned on WebGPU. And so if I look, for example, in the console here, I have navigator.notgeolocation.gpu, which is nothing more than an opaque object on the native side of the browser. So there's nothing in here. It has just the request adapter function, nothing more. And if I'm looking into another browser, that's my normal Chrome, which does not have WebGPU enabled, I can type in navigator.gpu, and it's undefined.
You're just using some command line flags or command line arguments to
Exactly. I'm starting. That's just for my own development workflow. I'm starting. In this case, I'm using Chrome Dev and Edge Canary and Chrome Canary because it can run in parallel with my normal Chrome for browsing. and you can only start the browser with command line if you close every tab and every window, and then you can start up with the command line. But if you don't want to start with command line, you can just go to Chrome //flex. It's in every Chromium-based browser, and then just search for WebGPU. And it's called unsafe WebGPU, this flag. And if you look in your Chrome browser, this will be disabled. And you can just enable it. Now, it's a bug of Chrome that it says it is disabled because I have enabled it via command line flags. Yeah, and it also works in Edge. And for someone who wants to try out this in Firefox, unfortunately, I get nothing running in Firefox. Yeah, sorry, this crashes. This tab is crashing. In Firefox, there is an about config without any slash, and then Firefox is claiming, "Be careful what you do here." But we are all hackers and developers. We know what we are doing. And then you search for WebGPU, and whoops, it calls dom.webgpu.enabled. This is also a flag. You have to enable it. And what I read in Firefox, you have to enable a second flag, which is called Web Renderer, GFX Web Renderer. And you have to turn this also on. But unfortunately, it does not work with my code because I'm using some, as I told, some buffer update function, which does not yet work in Firefox. Yeah, and also Safari on Mac has a flag. You just go to you just enable the developer menu, which maybe you already have when you're a web developer on Mac. And in the developer menu, there is a submenu where you can enable experimental flags, and there is a WebGPU flag. Yeah, that's how to get it running on each browser. Yeah, back to code a bit if you're still interested.
Yeah, for sure.
Yeah, with the GPU opaque object, you're requesting the adapter, and this case is it is asynchronous, so you have to wait until the promise is fulfilled, and after it's successfully fulfilled, then you can request the device with this adapter, and on the device you can access the queue. You can maybe have more than one queue. I've not tested this out, but it's like on Vulkan, you can have more queues. That's had nothing to do with WebGPU. It's just a resize observer and canvas handling and event listener. Yeah, and then you're done with the basic initialization. So with this part, and then now comes the swap chain part. For this, we will look into my GPU particles project because it is a bit better organized. So I have do many refactoring there, and yeah. So just look. Oh no, we are in a React component here. It's the wrong thing. WebGPU renderer here. Yeah, we have the.
Well, it's pretty cool that you're using it in a React project.
What do you say?
I think it's pretty cool that you're using it in a React project.
Yeah, I'm using it in a React because I'm using React many times, and this UI is totally created with React. It's nothing fancy. The color selector I have installed via npm. That's a ready-made component, and everything is React. Yeah, here we have the function which is called one time during initialization, and it's called every time the canvas will be resized. So when you're changing the size of the canvas or just changing the size of the window, then some things for WebGPU have to be recreated. In this case, the texture attachment things have to be recreated with the new sizes. And these are just these two things, the color attachment and the depth stencil attachment for the depth buffer. And yeah, here I have the depth things, and here is the color attachment. And here are some API functions on the device. Create texture is an API function, and so on. Just store them into member variables of the main render class, and if the canvas will be resized, it will be recreated. Yeah, and where we are? Yes, and then we do initialization of resources. So that's the biggest part, what you have to do before you start your rendering. That's in my diagram, this render pipeline thing here. You have to create your whole shading pipeline and so on. In this case, I have create a camera class which handles camera movement, which is needed for rotating this box. And then I have created many mesh objects, which I laid out into separate classes. So, for example, the box is a mesh object. The crosshair in the middle is a mesh object. I can also move this with my keyboard and attract the force somewhere else. I can also change the force, can do negative force, then the particles are moving away from my force. I can also change the gravity, though, and so on and so on. Yeah, so there are many initializations happening for the render pipeline, and yeah, so it's a bit of heavy for this talk. Here you see every file is a separate class here, and we have geometry handling, which handles in this case the mesh class, which handles the buffers, creating a buffer. Here I have a create buffer helper function, which creates a buffer on GPU. This is an interesting thing. The main concept of these modern APIs like Vulkan or Direct 3D12 or even WebGPU is you're creating a buffer on the GPU and on the CPU. So with this create buffer function, create buffer mapped, you're getting back two objects. One is the GPU buffer object, and one is nothing more than a JavaScript array buffer. This JavaScript array buffer is a writable array where you can put in your data, your vertex data in floating point values. And you do nothing more than say write into this write array object, and at the end you do an unmap, and with this write and unmap, the data will be copied from CPU to GPU, but not during rendering. It will be copied during initialization. In this case, it's already fast but it can block something. Yeah. Another interesting thing compared to from WebGPU to WebGL is that WebGPU only supports SPIR-V shaders, which does mean you have to compile your shaders before using them. For WebGL or OpenGL, the GLSL shaders will be compiled by the graphics card. So you put in shader source and say compile, then you do this for the vertex shader and also for the fragment shader, and at the end you can link both together, and that's it. And sometimes when you're changing states, you can initiate a recompilation during your frame loop, and this can lead into some micro stuttering because this recompilation can cost 10 or 50 milliseconds, which is too much. And with WebGPU, you have to ensure that you compile your shaders to the SPIR-V format. SPIR-V is like bytecode format, and then you put your bytecode shaders to the GPU. For this, I'm using a simple bat file on Windows, a batch file, and using the glslc.exe. This comes with the Vulkan framework. So if you want to use this, you have to download the Vulkan framework and use this exe. And then you use your vertex or fragment shader and compile it to a SPIR-V byte format. That's important to know. There is, at the moment, I have not tried it, there is a project which is called I think WebGPU GLSL, if I know. Yeah, GLSL lang. I have not tried it yet, but it's interesting and it's maybe easier to handle. This is a GLSL to SPIR-V compiler for the web and Node.js. It's nothing more than making this compiler code available through WebAssembly. Yeah, and that's it. So they're using this, and with this project, you can compile your shaders during the running of the website. Here, I compile my shaders and load them as oops, not there. Load them as the SPIR-V format. Both will work, but I have not tried the other way.
It is kind of interesting. So I can imagine if you would use something like WebGPU to do something crazy, where the user can provide input for like I don't know, you could always parameterize the shader, I think. But if you give some power to the user, you might have a need to recompile a shader at runtime.
Yeah, not necessarily. You have to create some uniforms for your shaders. So the shaders, the language of the shaders are still GLSL, a bit more modern than in WebGL1. And for example, we can have a look at my particle shader. This is the vertex shader. The particle vertex shader is only for vertex. Yeah, something goes wrong when I'm switching windows sometimes. It's for doing the vertex transformation. So it transforms the local position with model matrix, which in this case is always identity matrix but it transforms the position with view matrix, which is my camera matrix, and the projection matrix. This is nothing more than model view projection like in OpenGL. That's the same techniques. And the fragment shader does nothing more than put out the color of the particle itself. And here I have a uniform to control the color, and this uniform is controlled with this thing here. So if I changing the color here, I changing the data for the uniform, and I get a different color here. And for the particles, there is a third shader, which is called .comp. That's the compute shader. And it's also GLSL, but it has no output color like a fragment shader or output vertex like a vertex shader. It's just a compute function. It has every arbitrary input, and it can have every arbitrary output. So you can fully control which one is input and which one is output. And in this case, I have 2 arrays. Unfortunately, they are VEC4 arrays because of memory alignment, which is a thing in WebGPU you have to thought about. You can't use a VEC3 here. It must be 4 VEC4 or 4 floatings aligned. And I don't know how to a correct alignment from JavaScript. It's much more easier in C++ with a struct. You define the struct and you define some alignments and you're done. And you can ensure that you have the correct byte alignments. Yeah, I have 2 arrays, position array and velocity array. In the position array, we have X, Y, Z for each particle. So if I have 100,000 particles, this array will contain 400,000 floating point values. And this is exact the same array and from the size. And this is the compute code. And with the compute code, you have access to a built-in variable, which is called GL Global Invocation ID, which is like a thread ID. And you can use this as an index into the array. So each compute unit, each shader unit on the GPU get a different ID. And then I do nothing more than read from the array and do my particle calculation. So that's the updating the position at gravity. That's the collision for the box here. And if I turn on my force, I do calculate the force. And at the end, I write back the particles at the same position. So this array is read and writable. And the same array is used for rendering in for the vertex and fragment shader. So that's the concept of compute shader. And in the compute shader itself has also some uniform parameters. Uniforms in WebGPU are working like the same as in WebGL. They are for changing variables in your shader. So, but you don't want to change them each frame. So change them rarely, like when you want. So in this case, I have my force position, for example, which is nothing more than the position of this crosshair here. And if I'm changing the crosshair position, I'm changing the uniform in the shader, and the next calculation uses the new data here.
It's cool. Just one other thing. Is this your own extension you are using right here, right now in VS Code?
What do you mean?
Your shader extension? You
Yes,
wrote
of course.
just if anyone wants to have a great shader extension for VS Code, this is the one you need.
Yeah, the shader extension I have created 2 years ago, I think. I can link it in the chat. This is capable of each GLSL shader and also compute shaders and also the new RTX shaders for the RTX graphic cards.
Oh, that's cool.
Unfortunately, I have no RTX graphic cards, but
Me
but I
neither.
have some test shaders to test my extension against them.
But it is cool.
Yeah, it works with them, and yeah, if someone wants to use it, I hope I have explained it very well on the README how to use this extension. You have to download the GLSLang validator from Kronos Group, and for your platform, it's available for Windows, Mac, Linux, and then you can use this extension. And if one have any feedback, feel free to write an issue on GitHub, and there are rarely some feedbacks, and I try to fix them and implement new features rarely on it if needed. Yeah.
Now this WebGL code, no WebGPU code. I was thinking about WebGPL, WebGL. Now I'm getting confused.
Yeah, the same error I'm
I
doing
just made up a new API.
sometimes today.
WebGL. WebGL is pretty low level. WebGPU is also pretty low level.
Yeah, WebGPU is much more low level than WebGL.
Yes, I already think WebGL is too low level for me. So, and for a lot of people, so there are libraries that are built on top of WebGL.
Yeah.
Are there libraries built on top of WebGPU?
Yes.
So I can just do the basic 3D stuff without really having to go as deep as you're demonstrating right now?
Yeah, I'm not sure how the status is. As I showed the demos on the beginning, the forest with the trees, Babylon.js has implemented WebGPU, and blah blah blah. Our plan is to deliver a support with WebGL feature parity and the new WebGPU specifics in 4.1. I'm not deeply in Babylon.js. Oh yeah, they are already on 4.1. So maybe you can try it out with Babylon.js. And they had a demo. Yeah, where we are is, I think, an important thing. We currently only support a really small subset of what Babylon.js can do. So static meshes, instances, no bones or morph. Materials cannot change their defines after creation. Yeah, so there are some limits, but they are still developing on there. Unfortunately, I'm much more in 3GS, and not unfortunately, I love 3GS, but unfortunately, there is no implementation yet on 3GS. There is a big discussion on, I think, on the GitHub. And yeah, they are a little bit behind, and they are also a little bit conservative what's going on with WebGL 2 or WebGPU, because 3GS is so widely used today. It's the basic of A-Frame. It's used by many companies, also Apple using it on their websites, and my company is using 3GS since 4 or 5 years, and I think my camera turns off.
Oh. Yeah.
Yeah.
You stopped moving.
Yeah, my smartphone turns off. Sorry for that.
Your battery died.
No, not battery. It's getting too warm.
Oh.
Just turn off the camera. It's no big deal.
I can. Yeah.
Okay. Yeah. So there are discussions about WebGPU, but there is no implementation yet. Maybe there is. Maybe there is a side branch. Yeah, someone has created an experimental WebGPU renderer for 3JS in February, but there is nothing officially yet.
But it is kind of interesting. I think you mentioned the shader language is newer.
Yeah, it's not very new. It's GLSL, but version 4.5, and if we compare this to WebGL, GLSL,
Yeah, that's 2021 or something.
in I'm not sure. Let me look at OpenGLES. Hopefully, yeah, that's the welcome back to the version hell.
Yeah.
Yeah. I think this version is for the shading language. Let's switch to.
It's something I always run into. You use a nice tool to write your shaders, and then it just does not work.
Yeah. WebGL. So here, welcome back to the version hell. WebGL 1, which is specified against OpenGL ES2 and OpenGL ES2 using
ES2, yes.
using 1.00 version of shading language. So you have 3 different techniques with each have its own versioning. And next thing will be OpenGL ES3, and this is used by WebGL2, which is supported in Firefox and Chromium browsers only. So no Internet Explorer, no Safari yet. Only Firefox, Chrome, and all Chromium-based browsers supports WebGL2. And WebGL2 is specified against ES3, and ES3 could use shading language 3.00.
What do you think?
And
Should
this
we?
is what.
Sorry.
Yeah, and this is what I'm talking about. Compute thing. Compute shaders were introduced in OpenGL ES 3.1. Yeah, so they are not available through WebGL, unfortunately. And the WebGPU is very more open to this thing. You can use every shading language which could compile to SPIR-V. I'm not sure how to pronounce it in English correctly. I say or SPIR-V or anything. Is it called? If you are familiar with DirectX, for example, and not know anything about OpenGL and OpenGL shading language, you can write HLSL code, which is the shading language for DirectX, and using also the GLSL lang compiler and compile it to SPIR-V, and can use it in your WebGPU project.
That's interesting.
Theoretical. I have not tried it. And Apple also came up with some kind of new shading language for WebGPU, which is called WSL.
And not ISL. Or,
don't mix it with Windows subsystem for Linux. And I'm not tested anything with this. It's the new repository called. Okay. still not there.
It's so new, it's not there yet.
Yeah, it's so new that it's not there yet. Here, it has moved. It's called WebGPU shading language, and yeah, there is nothing much available there, and I don't know anything about it. I have not looked into it, but it should be available for WebGPU only, and I don't know if it's better or easier or more complex. I'm not sure.
I don't know if we need another
And
shader language.
yeah, it's another shader language.
I would like to see tools where I can just I haven't checked it, so it might be in there already. But maybe like Substance Designer, where you create some shaders or whatever, and then export those to that Spire V. That would be really powerful. I think
Yeah,
that would be if you have a tooling of that level, it will be a game changer.
I think there can be some tools. It's yeah, but overall, it's heavily depends on your use cases, and everything you define here is coupled to the application. So let's look at a more easier thing like this is a basic vertex shader and the basic fragment shader. This shader is you always have two shaders, a fragment and a vertex shader. It is used for rendering the lines, for example. And it could also be used for rendering a triangle or any model or something. And it's just the normal projection thing and handling of the input positions and colors via vertex colors and nothing more. And this location IDs you have to define for yourself. So you're starting at location 0 and then moving up to location 1, 2, 3. With the older WebGL code, you do not define location, you just define your attributes and uniforms with names and then get a location by name. But this kind of API is not available in WebGPU because it's also not available in the native backends like in Vulkan or something. But overall, I can imagine that there will be tools to spit out these shaders. They are all nearly the same. So you have a main function, which is essential. The vertex shader should have some inputs like the vertices and your transform matrices. This could be one matrix which you can calculate on CPU, but it could also be separate into 3 different matrices, and it should spit out a position in this case. This could also be written as another notation, so it's totally flexible. And the fragment shader is mostly for shading. So if you want to implement complex shading things and complex materials like PBR or anything, then you have everything doing here your calculation by fragment. Sorry. And the fragment shader has nothing more than outputting a color for your fragment, and the fragment is a pixel on the screen.
Yeah,
that's the shading pipeline since I think 15 years, and also in OpenGL, and they are also common in DirectX. And I think if you want to program at this low level, you have to understand how it works. On the other side, you have to use an engine like Babylon or 3JS when they are done, when they are ready. And that's with the same with WebGL. If you do not want to program vanilla WebGL at the low level, then just using the engines like 3JS, and with 3JS it's really easy to getting started. So you're just creating your scene, creating a camera and creating a renderer, and defining the size of the renderer and appending the renderer canvas element to the body, or you create your canvas itself. Then you're creating a geometry, for example, a box geometry, and give them a material, creating a material, and then you're creating a mesh object, put in geometry and material, and then add the mesh object, in this case cube, to the scene, move out the camera a bit, and then start rendering, and that's it. And
it would be great
overall
if you just have like a framework like this that just would take all that hard work you have to do to get something going.
Exactly. And that's this kind of technology like WebGPU is not for content developers. I think it's more for engine developers. It's the same like on desktop. Vulkan. I'm doing a bit of Vulkan in C++ a few months ago. It's you need about 1,000 lines of C++ code to rendering a triangle.
But that's with all of them. I've done WebGL in the past, and you have to write a tremendous amount of code to just get the triangle. The same thing for DirectX. Well, even going back further, my first programs on Windows I wrote with Pascal for Windows. And the amount of code you have to write to get a window on screen. It's today you just say I want to have a window, and you get a window, and there's frameworks that help you with that. But back in the day you had to write everything yourself, and then there came frameworks on top of that. Now I think there is a balance, and there's or a balance, an imbalance. There are no frameworks yet for people to build all of that, and
no, not yet for WebGPU.
You dove in and figured it out, and got it to work. But then the next level would be to implement this in a real application and show cool graphics that really need the power of WebGPU. And that would be, then you have to build your own framework right now. And then no one could use it because it's only behind flags. So nobody's going to invest that amount of time to build something that can only be accessed through flags. And as long as nobody is building anything for it, there's not a real need to move it away from the flags, I think. So there is this tension maybe.
That's correct. That's the same problem with WebGL. I followed the whole thing about WebGL because I started learning WebGL about 8 years ago. 8 or 7 years ago. And I followed everything what's happened on WebGL, on Chromium, on Safari, and so on and so on. And when WebGL was coming up on major browsers, also on Safari on iOS, I think it was 5 years or 6 years ago where it gets available. We and my colleagues are thinking about, okay, now we had a breakthrough. We had a breakthrough for gaming on the web, and but this breakthrough never happens, unfortunately. The technique is there, but no one writes AAA games in the browser. there are some small good games. There is a community for browser games and so on and so on. But no one does a big AAA game like Battlefield or anything other which only runs in the browser. And because there are some limits still, there is still an overhead and something, and yeah. And if there is no big usage, then the technique behind will die someday.
Yeah. Well,
On the other side, in the industrial business, WebGL is very interesting. There is one company called OneShape which creates a whole CAD system, whole CAD system in the browser, which is very good at the moment. And we are in my company using it for visualization in the 3D CAD sector, and yeah, many others using it for product visualization and so on. And looking at some low-level things, this is the whole renderer code, which is nearly 400 lines of code, only for rendering a triangle.
yeah.
And that's the hello triangle thing. So maybe you can maybe someone can reduce it a bit, but overall you need about 300 lines of code to rendering a triangle.
It's I think for a lot of people it's too much.
Yeah.
Now I did notice you using TypeScript.
When you're using JavaScript, it could be a bit lesser code, of course.
No, but
because TypeScript has a bit of code overhead.
Are there TypeScript definitions available for WebGPU?
Yes, there
Okay.
are.
But
There
then
are,
that might be, if you are exploring the language, it might or the API, it might be a great way to go from there.
Yeah, there's a better way of exploring the API, and there is the WebGPU spec. It's fully available, and if you see how
Wow,
how actual the date is
today.
Yes.
Wow.
There are happening check-ins on the repository each day or each few days. They're checking something in, and that's the complete spec of WebGPU. And you find everything here described, and also the API, which for example, if you look at create buffer, you have the function create buffer, which accepts a descriptor. This descriptor is of type GPU buffer descriptor, and here you have the GPU buffer descriptor.
Yeah, but it's still kind of complicated to all build without any help from IntelliSense. And if you're using a TypeScript definition, it just might give you less back and forth to the spec.
Yeah.
I've actually got one last question. Is there anything, an example, a demo that we should see that you say, well, this is, if you want to see WebGPU for yourself, you should go here, and there's this demo. That's the one you need to see. Is there anything available online where we all should go and
There are some demos. There is this repository by Austin Eng. Austin Eng is the developer at Google, which creates the implementation in Chrome. Maybe he's also developer of Dawn library or some part of this. He has he has a demo site. You should run this demo site in the correct browser. No, I'm in the wrong browser.
Hmm.
And he has also like hello triangle, which, yeah, it works.
Wow.
Takes a bit. He has also a bit of code here and rotating cube and two cubes. And it also helps me a bit, his code. He has
Yeah, so
some
this
instant
definitely
cubes.
looks like the place you need to go to
Yeah,
get started.
texturing.
Can you share that link in the chat?
Yes, of course. Sure.
Oh, this is cool. The render textures, render to
Yeah,
texture
that's
effect.
render to texture. Yes, and he has also some kind of compute thing,
Infinicubes, yes, Whitlaw.
the
Oh,
compute
yeah.
boards, which is some kind of a flocking algorithm. So they are sticking together if you run it a bit. And yeah.
I was looking at. I thought there was one that didn't do anything, but it was your mouse in the
Yeah,
middle.
he's searching for his family.
But
And
the flocking behaviors and
yeah,
those kind of things. Yeah, then you slowly go to the well, the flocking is a
yeah,
kind of simple AI thing, but you slowly move to the AI things
yeah,
again.
exactly. This is interesting. And there is also a guy on Twitter which has followed me and who is creating a very interesting site. Not a site, or a repository. Let's look at it in the browsing browser. Which is called Awesome WebGPU, and he takes every information together. So there is a curated list of where you should look. So everything is linked here, and it's a good entry point. So you have the link to the official community group of the W3C, then the repository of the specs, then the spec itself. Yeah, there's an article of Firefox Nightly, the thing, browser support, everything what I talked about. Then there is also a guy which has recently started a course about from zero to GLTF with WebGPU. So it's a very good explanation from him.
Are you in there?
And that's very great.
Yes, you are in
But
there.
unfortunately, at the yeah, I'm in the list. Um, at the moment, he has only two courses. Is he published 20th June? So 2 weeks ago, he has published the second part, and I think there some other parts are coming up here.
Yeah, it's cool.
Yeah,
It is. It is. It is. It kind of feels where it is right now, like where WebXR was 2.5 years ago.
yeah, exactly.
So there was this. It was already behind flags. It was not there yet. The spec wasn't fully implemented, but there were more and more people that were experimenting with it and trying it out and loving it. And well, WebXR is in Chromium right now. It is the flags are removed and it's out in the open. Oh, your screen share stopped. Are you still there? Am I still there? Are we still live? We should be live. Lost connection. Let me switch to my camera for a second. I'm not sure. I do have some lag here. Wait. That's better. There are some things going on. Yes, we are still live. We lost Donner. Well, since it is, we are ready.
It
you're
was
back.
your connection.
No, it wasn't my connection. No. I think I didn't see any dropping anywhere. You just your screen went black, and it could be my connection. I still have that killer thing running, and it might screw things up. I haven't tested it for a long time over
it
Discord.
could be my connection. I'm not sure. But right now it looks like everything is back.
Is there anything we need to discuss still?
I think we covered everything I know.
Yeah, well, then I think it was a success. The first web API Wednesday.
Yeah.
So I would like to thank you very much, Donner, for hanging out and giving us an introduction to WebGPU. I really like it, the API.
Me too. And
I think I always say the web grows stronger every day, and I think it really is.
Exactly, yes.
Right
now I'm developing another project. Maybe you have heard of it. I also do it on stream. I'm creating a ray tracer from a book which called Ray Tracer on One Weekend, and I have the first implementation done in TypeScript, and it runs on the CPU. It's very, very, very slow. Today I have run a picture in full HD with much samples, and it takes 10 hours to render.
Wow.
And on the next stream, I will start optimizing it using web workers. And after this is working, the next step will be to move out the computation code to WebGPU compute, to doing the full ray tracing computation on the GPU. That's my
cool.
plan.
Mind if I share the repository? I shared your
Yeah, you can share the repository if you want.
I think this is what you're talking about, the TS ray tracer.
Yeah, exactly.
Well, I think we all should go over. Well, there's nothing there right now, I think, but after the stream, everybody should go over to your channel and hit that follow button.
This would be very nice.
Yeah, thank you very much for hanging out with me. I think the last thing I'm going to do is go over the list of everybody that followed. Normally we do have the shout outs and sound effects live during the stream, but I disabled them today. Although I screwed it up in the beginning, they were only hidden. So we actually had to go into the configuration of the alerts, and I completely disabled them. So now I have to figure out a way of doing that better, that I can just turn them on and off if I want to, but that's for the next time. I think the next API Wednesday will be in a month. So I'm planning on doing this every month. Because it takes some time to prepare, and we should find another guest and find another subject. We will talk about WebAssembly. Maybe we can find somebody that's really into WebAssembly and explain something. Otherwise, I'm pretty sure we can find someone that knows about WebUSB or WebXR, maybe. So Lila Hamstern subscribed today again. Lila, if you're still there, thank you so much for the sub again. Normally I have the light effects and all going on, and my camera was off, but the light did blink during the subscription. Also, which was kind of like sad, I have a new host effect, and we got a host by, let me check, was early on. we got a host, but the sound effects, Swiss Da Vinci hosted us, but we didn't have the sound effect because I turned it off. So we still haven't seen it live, but someday it will come. And then we have a couple of follows: Unseen Energy, Swiss Da Vinci HD, Andy DE. I'll follow during the stream. Thank you all so much for joining and hanging out. I'm going to give one. If you want to have a chat and you want to know everything that's going on in between streams, please head over to the Discord. I think we might discuss what we're going to do next Web API Wednesday. I will be back streaming tomorrow. That's the plan. We will do Web XR tomorrow, probably, because I have a talk next week. And I still need to do some more demos, so I think we're just going to work on the demo. We were trying to get a Pokemon Go kind of app, Mokipon, I think we called it. So I'm going to continue that tomorrow. Same time as we started the stream today, 9 p.m. Central European time. Yeah, I think that's it. Let's see if we can rate someone. I think we rated the Michael Jolly a couple of times. I'm not exactly sure what he's working on. But it's always fun. I hang out there a lot, and I hope you will join at least for the raid. Say hi, and then if you don't like it, feel free to go somewhere else. I will see you again tomorrow, and with that, thank you all for joining. Bye-bye.